Okay, so we're back for part two of our geologic mapping, digitizing it. And so, yeah, so we've got our kind of area of interest and digital topographic data to help us with our geomorphic and geologic mapping translation. But, the reality is you will have produced some field maps that you'll need to bring in. I haven't yet mapped this area myself, and I'm making these tutorials ahead of our week. So to cheat, I've basically taking a screen cap of an existing geologic map for the area, which is not as good as you guys will be producing in terms of resolution, but I want to show you how we would bring your mapping into GIS. So we're going to georeference your scanned maps. So you'll need to, bring your maps into a digital format. You could take a photo of them. It would be better to use a scanner that is kind of ortho flat rectified. But if you can manage to get a over the top direct image of it, it may work as well, especially since we're going to be kind of adjusting the line locations using the digital maps as well. Yeah, so I've got my scan map here. It doesn't have any geographic positioning, but I can bring it into GIS. It doesn't show up where it's supposed to because it doesn't have any positions. But if I right click on it, I can say zoom to layer, and here it is. Okay. So, it basically, this is like a, I don't know, a 1 to 100,000 scale map. It has some fault traces, probably don't look too crazy different than your own. But the fans are just like two classes, I think. QF, old, and maybe younger. And you may have more classes than that. I hope you do. And then also has a little bit of geology and young alluvium. And so I'm just going to use this as demonstration for first how to georeference the image, giving it real world coordinates. And then the next video will demonstrate how to digitize your field mapping. And then from there, the next video after that will refine your field mapping. Okay, so first let's georeference. Okay, so if we click on imagery, I believe that's where we want to go. And then you'll see this georeferencing pane. So I can click that. Okay. And then you can see a new window has popped up over here. Okay, and so I have highlighted existing geologic map. That's what I want to georeference. And what you need are control points. And this can be tricky. Ideally you'd have like survey monuments or something to get this really accurate. But you can use other things, like if you know where the fault crosses the highway or something like that, or if you just know where the fan crosses the highway. So I'm going to try that. So I'm going to have the highway here. Oh no, I have the intersection between the road leading up to Merker Canyon and the big road here. So I'm going to click that as my first control point. And then I'm going to zoom over to to the other maps, and I'm going to say zoom to that layer. And I'm going to turn on the world imagery. And then I can find those road intersections and click right there. And you can see that it's in the right position, but the scale is not correct. And that's what you should expect. Now, as we add in a second control point, the scale should become more correct, but it might be warped. And then as we add a third point, it'll get better. And as it gets more and more control points, we can do different types of stretching for the georeference. So at first we're just moving it, and then we're stretching it. And then we may do a linear stretch or a polynomial stretch or more, depending. Okay, so what else do we see in here that we can notice? Okay, I can see these two little roads coming here, and I can see them on here as well. So I'm going to use the first intersection there. Should be about right here. Okay, the scale is getting much better. And since I have it, I'm going to do the next one. I just have it. And now this time I have to turn this one off. It really doesn't need much adjustment, which is good news. I can tell. Yeah, I guess it should probably be here. Then I'll turn it back on. Now that, because it's stretched a bit, because I told it that it wasn't quite right. All these control points are along the road. Now the road looks a little off over here. Don't seem to have any of these other roads on here. That's a little difficult. I can see a different geologic unit poking out here with alluvium. Might be able to use that. There is a Jeep track here. Hold on. Jeep track. Right there. Turn this off. Jeep track, right? Turn it back on. So Jeep track leaving the alluvium here. That's going to be my next control point. Jeep track leaving the alluvium. Where? All right, here. Turn this back on. Yeah, that doesn't look as weird now that I have another control point. So you can see this is somewhat tricky. We don't have a lot of control points, but it's actually looking reasonably better now. Look at this. So and see the rocks versus the alluvium maybe showing up in roughly the right spot. I'm going to try to get the edge of the alluvium right here above the fault. So it needs a slight shift over. Don't know if this little weird thing is in the right place. It might be out of our mapping area anyways, so I'm not going to worry about that. Do I have any more roads on here? This kind of looks like a road, doesn't it? Road intersecting alluvium right there. Okay. Gonna be a little tricky. This feel like it needs to be adjusted over here. Now, hopefully, yours will go smoother, and you have a couple of different maps. You're not just using a geologic map, but you have base imagery, which is actually this same base imagery. So you, in your imagery, may be able to find specific corners to these little Jeep tracks and things that you will be able to georeference on, which I can't with this map. But once you've got it to what you want it to be, you can like basically finalize the georeferencing. Now there's a couple of different types. So right now I don't have many control points. So I have if I look at my table, I have 6 control points, which allows me to do up to a second order polynomial. But I don't really recommend that with only 6 control points. Here, I'll do it and you can see why. Boom. It's no good outside of your control points. It might be good within the control points, but no good outside. So if you only have like 6, 5, 7, stick to first order polynomial um, uh, stretching. Okay, so I'm going to update the georeferencing transformation of the source raster dataset. So that should, I believe, save that um, raster as a world file. So let's see if that happens when I press save here. Now, there's the same folder, and now you can see existing geologic map now has a JGWX file and also this XML. Those are those world data about the positions of all the pixels in that. So it is now a GIS file. So it has been saved. So I can close the georeferencing. It'll stay where it's at. All right. So yeah, that video is about georeferencing your scan field map. Okay, so we'll stop this video here, and the next video will be about digitizing your field mapping.